So next, we are going to welcome Sebastian Sanchez from with Breaking the Wall of Mining Waste through Biomining. Welcome.
Okay, thank you for the introduction. Again, my name is Sebastian, and today I want to talk to you about breaking the wall of mining waste through biomining. The mining world faces a paradox. More rocks need to be mined to obtain the same amount of metal. In just over a century, the grade of metal ores has plummeted 2 to 10-fold. But meanwhile, the race for modernization never stops. And today, more than ever, sectors like artificial intelligence, renewable energies, defense, and countless others are driving an ever-growing demand for metals. Copper is a great example. By 2050, we might have to mine as much as we did for the past 125 years just to meet demand. And we all know what that means. Bigger mines, more energy consumption, and especially far more waste. And this is no small matter. Mining activities around the world already produce about 100 billion tons of solid waste, which is a bit over half of Mount Everest, every year. And there's a specific group of minerals, sulfides, that are intensely being mined for holding many of the key metals for modern industry. But as their mining waste builds up, so grows another problem. They all oxidize, releasing acids and heavy metals into water bodies and neighboring communities, not for decades, but for centuries. This waste isn't garbage in the conventional sense, though. It still holds significant amount of valuable metals, albeit too diluted or not in the right form to be processed. The world requires of innovation. And here's where VivoOr comes in. We are harnessing microbes whose appetite for sulfides rivals ours. In a more literal sense, they eat them. Through a process called biomining, these microbes can turn millions of tons of dangerous waste into an untapped leftover treasure. And here's how it works. First, we sequence all of the DNA in mining samples to identify which microbes call those rocks home. If we find any promising candidate, we try to grow them and put them into groups tailored for the task. Think of them as a rock band, each of them playing a role to create a groundbreaking performance. Finally, we put them into optimized bioreactors, feed them the mining waste they came from, and obtain a wide variety of metals, as well as stable forms of common contaminants like arsenic. With extraction efficiencies often over 90%, we're not just recovering metals, we're physically removing contaminants from the environment. Even better, byproducts of biomining, like acids and solids, can be repurposed in the production of fertilizers and building materials, contributing to real circular economies. As I said, today more than ever, we want more computers, satellites, medical devices, and a myriad of other technologies to live a more sustainable, healthier, and comfortable life. But as the consequences of our actions grow to the size of mountains, it becomes harder to turn a blind eye. With VivoOr, we want to show that some of our largest problems might simply require microscopic solutions. Thank you.